So we started this series 2 weeks ago that we're calling Wonder Junkies, and really the design of the series was to explore the places in the text where, going all the way back even pre-King David, people understood that creation was a means by which we can know God. That there's these Psalms in particular that talk about the two books, that we have the Bible, we have the text, and it is central in its role in helping us know and follow God. And yet, there's also this other book, if you will, and it's called creation, and the text tells us that it is screaming information about who God is and what he's like. And so for the last couple of weeks, what we've been exploring is, are we attentive to what it's saying? Not in any way suggesting that creation is divine, of course not. Not in any way suggesting that we are to worship creation, of course not. But to say that God is the artist, he's the creator of creation, and thus we can know him better by being attentive and present among creation. We've been exploring ideas like, well, wait a minute, maybe when God feels far, there's actually a relationship to your distance from creation. I mean, maybe several layers of consumerism and construction can actually cause God to feel distant. Psalm 8, this is David. He says this, I'm starting in verse 3, when I look at your heavens, the work of your fingers, the moon and the stars that you have established. So David's like, well, when I lay in the grass and I stare at the sky, then he says this, I ask myself, what are human beings that you're mindful of them, mortals, that you care for them? So David's experience, and it happens in several places in the text, is he looks at creation and he sees how magnificent and enormous it is, and he's like, whoa, like it is so huge, and I am so tiny. What are people that you love us? He's confronted with the degree to which God values and loves people in light of their size compared to the rest of the created order. And so this morning, kind of in keeping with the series and our desire to not just blah, 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 this stuff, but to actually create experiences that allow us to explore Wonder Junkies, we've invited Dr. Kelly Cline from Carroll College, who teaches astronomy and math over there, and we just asked him, will you just blow our minds with the cosmos? Will you just confront us with their size and beauty and all that stuff? So would you give it up for Kelly?
All right. Well, hello and welcome. I really appreciate the chance to come and talk to you about this because I'm in astronomy, and it's just absolutely amazing what we can see about the universe and what it is and how much we've discovered recently in the last few years, the last 5 years, the last 10 years. I'm going to show you basically a slideshow. I'm going to give you a tour of the universe, what we can see. And most of these pictures are young. They're new. They're things that we've taken in the last 5, 10, 15 years, sort of thing like that, and just are extraordinary, that give us an extraordinary view on what's out there. So here's a couple, here's a little picture at sunset. And I guess the first thing I want to really encourage you to do is enjoy what we have here. We're lucky to live here in Montana, where we've got real skies. We can see all kinds of stars just from here in town. I love taking my 4-year-old daughter outside and pointing out Orion and the constellations and the Big Dipper. I mean, just right by our house. And man, you get out of town just a little bit. You go up. I love going up on McDonald Pass or something like that, and the skies are amazing. And the longer you stay, the more your eyes adjust, and you can see all kinds of stuff. So I'm going to show you, just starting with some pictures here. So we can see the constellations. You go out at night, you can see the stars. You can see things as they're really going on. I mean, there's a painting which was not painted by any human hand right there. That's just absolutely amazing. That's a picture of the Tetons. Got a couple of planets there. And now every picture I'm going to show you, there's nothing here from Photoshop. This isn't any artist conception. Some of these are crazy long exposures to bring out the colors and enhance what we can see. But it's all real. These are all real pictures of the universe as we can actually see it. And it's beautiful. And it's immense and extraordinary how fantastic and amazing this universe we live in is. And one thing you'll notice as soon as you start looking at things and watching for a bit is that it's in motion. It is not a fixed picture. It's not up on the wall. It's constantly in motion. You look at this and you see the sky. This is about a half-hour long exposure. So you can see the stars are rising up in the east here. They're setting in the west, and they're all moving in circles around the North Star up there. The heavens are dynamic. They're constantly moving. They're constantly shifting and changing. So you watch them for a period of a few minutes, a few hours, and you can notice that they're developing. They're changing. Nice picture here where you can see the stars as they slowly move in a 24-hour cycle around the North Star. Of course, it's really the Earth that's spinning. But when you look at the heavens, you see the stars moving in circles around the North Star there. I love this. The northern lights are awesome and amazing. We get them sometimes here. And you never know. You never know. Every time I've gone out at night, I've always seen something I didn't expect. Something I never thought I would see. And so you just never know where you're going to see something wonderful and extraordinary like the northern lights or something like that. So let's start our tour. Let's start by looking at the closest thing in the whole universe to the Earth, and that's the moon. And the moon is beautiful. And the moon is a world. When first ancient peoples looked at the moon, they thought, okay, the moon is just this idealized, perfect sphere, nothing going on there. It's just of this. And then we start looking with real telescopic pictures. And I love seeing this terminator here between day and night on the moon. And you can see craters, and you can see mountains, and you can see plains, and you can see volcanoes, and all sorts of amazing structures. The moon is alive. It is complex. It is a world like the Earth. You can see that the phases of the moon are not caused by the Earth's shadow. That's just the day and the night side of the moon. These big volcanic plains out here, these highlands, craters, all sorts of stuff going on there. Look at that. There's a detailed picture. You can see the immensity of this world. And that's the closest thing to us. That is the closest piece of our universe, right there next to us. And then we can look out around. So here's the moon. And there's another crescent that we can see here. But that's not the moon. That's our next door neighbor. That's the planet Venus. That's the planet Venus right there. Venus goes through phases. And the big difference between the planets and the stars, when David was out looking at things, is that the planets move. This is a multi-day exposure. So here's Venus on one day, and the next day, and the next day, and the next day. And the planets move with respect to the stars. I mean, the stars of the Big Dipper are exactly the same now as they were thousands of years ago. They make the same constellations, and Orion, and all these different constellations. The stars, since they're so far away, they do not appear to move from our perspective. But the planets do. They're in constant motion. They move through the stars. The word planet comes from the ancient Greek word meaning wanderer. So they wander through the stars. And then we go to the modern age and we can start getting telescopes and we can see that Venus goes through phases just like the moon does. You can have a crescent Venus, you can have a quarter Venus, a gibbous Venus, a full Venus. And then we go to the space age where we can really start taking pictures of this and exploring. And we discover that Venus is not just a light in the sky, not just a speck that moves across the heavens. It is a world. We start looking here and we can see, okay, there's some structure to this. So what do? We dial up. There are other forms of light other than the light that our eyes can see. And so we bring in ultraviolet light. And you can see that Venus is covered with this amazing blanket of clouds. And they never break. They never break. Venus is always enveloped in this thick blanket of clouds. So if I want to explore Venus and I want to see what's going on there, what do? I can't just take pictures from orbit. I got to use other forms of light. So we bring radar. So we've had the Magellan space probe, which orbited around Venus, which peels back the clouds and lets us see what's going on in there. And we see that Venus is an amazing world. These are lava flows. There are huge volcanoes there that pour forth these big lava flows across the plains of Venus. We find mountains, we find valleys, we find craters, we find that Venus is in motion. We can see different places, different views of Venus. We can see where volcanoes are erupting and pouring different things out there. Here's a big close-up view, these big lava domes pouring out. Venus is hot. Venus is not a pleasant place to visit, is it? Don't go there. Seriously, it's bad. And so we see these volcanoes across there, these different forms. It's like the volcanoes erupting on Hawaii is the sort of volcanic activity there. And Venus is almost the size of the Earth. It's the Earth's twin from a great distance. Yet you go down under this, and it's hot enough to melt lead on the surface of Venus. Crazy hot, an amazing place. Here's our other neighbor. This is Mars. And again, this is one of those super exposures. So you got Mars here and the next day and the next day. And it moves back and forth across the stars. This was puzzled people. People wondered about this. How can this happen? Why does it go this way and that way and forward and backwards? And the answer is the Earth moves. The Earth is part of this. The Earth is not at the center of things. The Earth is just one planet. When we look at the other planets, we're seeing worlds. And so when the Earth goes past Mars, when it laps Mars in its orbit around the sun, that causes Mars appear to go backward from our perspective. And so people began to understand this. And then we go to the space age. We start taking pictures and exploring. We see that Mars has polar caps, just like the Earth does. It's north and south pole. It has seasons. It has winds. It has, look at this crazy, look at this. This is amazing. That is Valles Marineris. Valles Marineris makes the Grand Canyon look like nothing. This is a great canyon that would stretch all the way from the east coast to the west coast if you laid it down on top of America right here. There are mountains, there are valleys, there are craters. So what do? We send space probes that take close-up pictures. Here's the atmosphere of Mars. Mars has weather. Mars has winds, and it has seasons. And it has effects on things. So we can send their space probes down to drive around on the surface, see different types of soil. Mars is like a desert, an amazing frozen desert. These are sand dunes on Mars taken from orbit. We can watch these evolve and change over different times. Here's some of the oldest parts of Mars where you can see there used to be water flowing on Mars. There used to be rivers on Mars. There used to be lakes on Mars. There used to be ancient seas on Mars in the distant past, but not today. Its atmosphere is thinned. Now it's more like a frozen desert. You look out across there, you can see stones and rocks. There's frost on Mars. You dig down, there's permafrost under the soil. Look at this. This is near the polar regions. These are sheets of ice reflecting the sun's rays, cliffs. There's so much to explore there. Look at these different layers. We think that all these different layers were caused by some of the ancient seas on Mars, coming up at different layers with different tides, and then now all covered with all this frost enveloping the planet as it's turned into a frozen desert. We have so many pictures, so many images that we don't even have enough people to begin to digest and understand this, to look for all the patterns and all these wonders and even begin to try to understand what we're seeing. We have more probes orbiting. We've pulled back more pictures out of Mars in the last 5 years than all the rest of all throughout human history, even the telescopic pictures. And look at this. You can see these complex structures. This is huge. This is an enormous mountain range on Mars. Here's another planet. Here's another planet. Look at this. We're looking into the sunset, and this is another one of those one day, next day, next day. The planet comes up out of the sunset and then dives back down again because this planet is right close to the sun. This is Mercury. Mercury is hard to see because it's always right near the sunrise or the sunset, always close to the sun. And then we send our probes out to Mercury. About half of the surface of Mercury we didn't have pictures of until 3 years ago when this probe we call Messenger finally got there. And at first it swung around the sun and then settled into orbit around Mercury and is taking these pictures, and we see these cracks across the surface of Mercury as the interior of this planet cools. We see craters. In many ways it looks a lot like our moon. In many ways, it looks a lot like our moon. Just look, craters on top of craters on top of craters. Craters are what happen to a planet when other stuff isn't happening, because there's junk in space. There's rocks and there's things that smash into the surface, dig out these craters, and they're just the surface of Mercury is what we call saturated with craters. Look at this one. This is beautiful, how there was an impact that came out and then reverberated back in there and created a second ring inside of this immense, immense cratered surface. You can see little bits of tiny little volcanic cones here in this immense, immense plain stretching out in front of us. How did this happen? How did this come about? It was a giant impact, and you can see streaks of material were knocked out and was stretched out across the surface of the planet. This is a world. This is a whole world, a whole great expanse to be explored and understood. It's a harsh world, close to the sun. You can see these shadows of the sun across all these craters. And then we look out. And we look beyond. And so we've got Mercury and Venus and the Earth and Mars. And these are solid rock planets with mountains and valleys and craters. And then we look beyond into the outer solar system. And we discover a whole different type of world. A whole different sort of thing. I don't even know why we call Jupiter a planet. It's different. Yeah, it's a light that moves through the sky. But you get there and Jupiter is immense. It is fantastic. It's mostly made of gas. There are no craters or mountains on Jupiter. It's the swirling ball of gas. It's huge. Jupiter is fantastic. It's an amazing world. If you took all the rest of the planets of the solar system and together, Jupiter is 2.5 times more massive than all of them combined. Here's one of its moons. There's its moon Io. It's almost like its own little solar system there with these immense moons. Here's a nice picture where we look at the clouds covering the surface of Jupiter. Here on the Earth, our clouds are all made of water. Jupiter has clouds of methane and ammonia and ammonium hydroxide and all sorts of things. And it's constantly moving. It's constantly dynamic. It's always remaking itself. It spins amazingly fast. Jupiter spins. A day on Jupiter lasts only 10 hours, but Jupiter's 10 times as big as the Earth. So that causes its clouds to line up in the east-west bands, just like we have our jet stream that always goes west to east here on the Earth. Well, if you spun the Earth up this fast, then all of our clouds would line up here on Jupiter. You got these amazing storms, like the Great Red Spot. That is a storm that's twice as big as the Earth. Its speeds are twice as fast as any hurricane, and it's been raging for 400 years. It's an amazing world, an extraordinary world. There's a nice close-up. You see these different storms that form between these different cloud layers that go this way and that way and are constantly changing, constantly in motion. Here's an infrared picture. We go to a heat camera so we can see the Great Red Spot and these other storms are deep. They dredge up material from deep inside the planet. It comes boiling up through the deeper layers and brings warmth with it. And so then when we turn on our heat cameras, we see this. Here's some auroras. There's northern lights on Jupiter. Jupiter has an amazing magnetic field as well. It is fantastic, and it's constantly changing. And every time we take a picture, it's different than every other picture we took. And it goes right down to the level of our resolution. We'd send out another camera with 10 times the resolution, and we see dynamic things in the clouds at a level of detail 10 times more than what we saw. We are not even anywhere close to being able to see what all is going on in this amazing world. And Jupiter, in a way, has its own solar system. It has its big moons. This is its nearest, its closest into the big moons. This is Io. When the very first space probes went out to the outer solar system and they brought astronomers together and said, okay, let's plan things out. What are we going to see? What are we going to discover? And they thought they'd be all like Mercury. They'd be all like covered with craters on craters on craters. And then you look on Io and there are no impact craters on Io. There's crazy volcanoes covering this, pouring out different sulfurous flows of lava and material. Every dot here is another there's more volcanoes erupting on Io than on the Earth and Venus put together. It is the most volcanically active object in the solar system because Jupiter's gravity stretches and squashes it and heats its interior. Here's its next moon out. This is Europa. Here's a whole bunch of different shots of Europa. It's covered with cracks. This is the smoothest object, the most perfectly spherical object in the solar system. And it's got this surface which is covered with all these cracks and these different colors of material leaking through. That surface is water ice. That's the same ice that is frozen at the poles of the Earth. And we take these high-resolution pictures and you see these crevices and these cracks and these glaciers. And there's water ice there, and you can see it's almost like pack ice, like material floating in the stuff underneath it. And it is. If our calculations are correct, there is underneath that crust of ice on Europa is an ocean of liquid salt water 100 miles deep. There's more water in the oceans of Europa than in all the oceans of the Earth. What's going on there? What's going on with that? You can see these chemicals. This is an enhanced color picture allowing us to see the chemicals oozing up from underneath the cracks in the icy surface of Europa. What a world. What a world. Here we can see where there's warm water that's welling up and melting these round things in the icy crust of Europa. What's going on there? We got to get more probes out there. We got to figure out what's going on. There's the next moon. Again, it's tiny compared to Jupiter, but that's the biggest moon in the solar system. It makes our moon look tiny. This is Ganymede. This is another moon farther out. You can see this dark surface of Ganymede, and then these impact craters liberate the white ice underneath there. This is when you go out to the outer solar system, it's cold there. So things like water act like rock does here. You have volcanoes of ice erupting out on the surface of this. It's amazing. Look at this. Here's a close-up picture of Ganymede. So you've got this dark powdery substance filling in these round craters. What is that? Why does it happen that way? We do not know. Nothing's ever landed on the surface of Ganymede. Nobody knows what that's going on there, how that develops, how that changes. It's an amazing, fascinating thing. Here's another big moon of Jupiter. This is Callisto. Again, a dark, kind of crusty surface, and then these bright patches where something smashes into the surface and bright, shiny ice, methane ice, ammonia ice, water ice. Look at this. Look at this. Here we got the sun that allows us to see these mountain ranges on Callisto. There's sunset on Callisto. Look at how this cliff then sends its shadows back around at this dark, powdery material, filling in the darkness of these craters, these bright peaks pointing out there. It's just crying out to be explored. It's amazing. And then we go beyond Jupiter and we got Saturn. And Saturn is the crown jewel of our solar system. It is amazing. The rings of Saturn, you can kind of get a sense from this picture. We got this Cassini space probe out there right now, orbiting around Saturn. And the rings are thin. They're so amazingly thin. They're about 100 yards thick. is about how thick they are. And yet they're like 10 times the diameter of the Earth from one side to the other. You can see through them. They're made of billions of chunks of ice, billions of chunks, of tiny chunks of ice, all orbiting around Saturn. Each one like billions and billions of tiny, bright, shiny moons. And you can see their structure to them and complexity to them. Look at this. You can see through them. They're transparent. You can see the stars behind the rings. Look at these spirals, these waves propagating through the rings. How does that happen? What stirs them up? What causes that to happen? They're affected by Saturn's moons. Here's one of its moons that dances through this ring, braids it into these complex patterns. How does that happen? Why does that happen? Where did the rings come from? What makes them be that way? You look at this and there are just so many questions to ask. We're just overwhelmed by the enormity of it all. It's just amazing. I love this picture. This is the sun is on the other side of this picture. So our Cassini space probe went around behind Saturn and is taking a picture back at Saturn with the sun and backlighting it so you can see the atmosphere of Saturn, then you can see the rings. And you can see these dusty ice crystals all surrounding Saturn. The rings of Saturn are made of pieces of ice all the way down from just tiny ice dust to snowflakes to snowballs to big chunks of ice the size of houses, constantly orbiting around, smashing, changing, dynamically changing. Look at this. This is one of Saturn's moons. This is Hyperion. Look at that world. Look at that amazing world. It's like a sponge of ice and material. And what is it? And how did it get to be that way? And, here's another one. This is Enceladus. I love this moon. This is an amazing moon. There are geysers of liquid water that erupt out there like volcanoes, spewing out. So somewhere underneath Enceladus, there's liquid water there. Cracks. This moon is about the size of Montana. It's an amazing thing. Look at this moon. Look at these cracks across there. This is changing. This is dynamic. And yet you're all saturated with amazing, crazy numbers of craters there. What's going on there? This is probably the most amazing moon in the solar system. This is Titan. When the very first space probes went past Titan, they took some reddish orangish pictures on it. It looks like a ball. It's the only moon in the solar system with an atmosphere. It has air. Its atmosphere is twice as thick as the Earth. And what's its atmosphere made of? It's made of nitrogen, the same gas we're breathing right now. But it's 10 times as far from the sun as we are. So it's amazingly cold out there. And so then we sent out Cassini and we tuned it out so we can see through some of those clouds. And you can see some of the structure there. And so then we sent a probe that actually descended down through the atmosphere and took pictures like this. That's a coastline. Those are islands. And this is a sea, but that's not a sea of water because we're so far from the sun. Water is frozen out at these distance from the sun. Water freezes so it's stronger than steel. It's like rock out there. That's liquid methane. That's liquid natural gas. That's the same stuff I use to heat my house. And yet out there are oceans of it. There are lakes of it. There are ponds of it. It rains from the sky. They've got a water cycle out there, but it's like with methane, with natural gas. There are rivers of this stuff floating down to the sea. Thank goodness there's no oxygen out there. Otherwise it could burn, but it won't. It's an amazing world. Nobody dreamed of that. Can you have rain of other chemicals and rivers and oceans and seas and lakes? Every time we send a new probe out, every time we build a new kind of telescope, we discover all kinds of crazy things that nobody ever guessed was out there. I had a professor in school who would list, okay, what are the top 10 discoveries of the last 50 years? And we'd throw them out there. We'd brainstorm things. And he said, now, okay, of this list of 10, how many of these were things which were theoretically predicted here beforehand? And how many were just like somebody building a new telescope and being like, wow? And like 8 or 9 out of the 10 were always just we sent a probe out there. We built a new telescope. We saw something that nobody ever dreamed was possible. Here's Uranus. Uranus with its rings and its moons. It's another one of these gas giant planets, 15 times the mass of the Earth. It's a little bit featureless. There's not as much weather going on there, but look at those beautiful, beautiful, beautiful rings. Look at those rings. And it has its own moons. It has its own fascinating, complex geology. Crazy, amazing. This is Miranda, one of its most amazing. Look at these different features. It looks like this moon was broken apart and then put back together. Wrong. It's an amazing thing. Here's Neptune. Nice, beautiful thing, and there's its giant moon Triton. Neptune, we get out as Neptune. Neptune is so far from the sun, we figure there's going to be any weather on Neptune. How could there be weather? Weather here in the Earth is driven by the sun, by the sun's rays. That's what creates clouds and winds and storms. Neptune's going to be dead, not a chance. You look out there at Neptune. Here's a false color image. Here we're looking in the ultraviolet so we can see more of the activity. We go to a visible picture and there's storms on Neptune. There's activity on Neptune. There's clouds. There's these dark patches. Neptune is a dynamic thing. The fastest winds in the entire solar system are swirling around on Neptune with these high altitude clouds underneath these methane and all these different structures. How did this happen? What's the energy source? There must be some sort of energy source inside of Neptune pouring out energy, driving all these crazy storms. Look at this white fluffy clouds in the middle of this dark stormy spot swirling around in the fastest winds anywhere in the solar system. They're almost supersonic. Look at this. Look at this. This is Neptune's moon Triton. We call this cantaloupe terrain. You can kind of see why. How does that happen? What causes that to form? What is that? It's an amazing thing. Triton is an astonishing thing. We see geysers and eruptions out of this thing, building this, flows pouring out across the surface. It's a dynamic, it's a changing, it's an active world. And if there's one world in the solar system which is like Pluto, it's Triton. Triton was captured by Neptune sometime in the distant past. Maybe Pluto looks like this. We don't know, because right now this is just about the best picture we've got of Pluto with its giant moon Charon, 2 other moons, Nix and Hydra, that were found by the Hubble Space Telescope about 5 years ago. This is about as good as Hubble can do right now, and we've got a probe going right out there. It's the fastest rocket ever built by human hands, and it's screaming out there. It is past Jupiter. It's on its way to the outer solar system, and it's going to pass Pluto in about, 5 years now. Who knows what it's going to see? I guarantee whatever I could predict, it's going to be different than that. It's going to be different than that. And so there's the planets. But I got to tell you about the most important thing in our solar system. We got to visit our sun, because our sun is the source of all our life and energy here on Earth, and the sun is immense. It is enormous. You put together all the planets, Mercury, Venus, Earth, Mars. You put together the big ones, Jupiter, Saturn, Uranus, Neptune. You put together all their moons and rings and comets and everything in the whole entire solar system. Our sun is 1,000 times more massive than that. Our sun is immense. Our solar system is the sun. And a couple of minor details. That's what our sun is. And we can use all these different forms of light to see how active it is. There's a big giant prominence of hot gas pushed up out from deep inside the sun, erupting out into space. Where does that come from? How does that happen? There's magnetic energy. The sun is crazy, super magnetically active with these streamers coming out into space as the sun's energy boils out there. The whole surface, outer 30% of the sun, is undergoing convection. It is boiling. Hot gas rising, cool gas sinking. These convection cells are near the size of the Earth. Here's more of these prominences. It looks like grass growing here in the sun, but this is all magnetic energy coming out of the sun. And it's seething, and it's turbulent, and it's violent, and it's boiling, and yet there's order to it as well. Sunspots appear in a regularly well-ordered 11-year cycle, appearing near the equator, boiling up, getting farther and farther from the equator. Then the sun's entire magnetic field is entirely destroyed and rebuilt, pointing the opposite direction every 11 years. The sun is an amazing place. This is an ultraviolet picture, and this is what a sunspot looks like in ultraviolet. It's a wonderful, wonderful world, and we're just barely beginning to sense of it. Here's the sun's corona streaming out away from the sun during an eclipse. You can see these helmet shapes coming away from the sun. Millions and millions of degrees. Active, dynamic, changing, never the same. There's a sunspot, a big giant sunspot, all magnified. That's an object the size of the Earth, a magnetic storm on the sun the size of the Earth, this dark region in the center, then this material, magnetic field lines combing away from it, granulation, convection surrounding it. How does that happen? And then we look at more. There's Devil's Tower over in Wyoming. And we see that our sun is a star, just like any other star in the sky. The stars are suns. Our sun is a star. The only difference between the sun and any other star is it's our star. We happen to be close to it. If you flew up next to any star in the sky, it would be very much like our sun. You fly away from our sun, and what do you see? You just got any other star in the sky. And we see that all these stars are arranged in this amazing, amazing galaxy we call the Milky Way. The galaxy comes from the galaxos, meaning milk. Look like this milky glowing braid across the sky. These are long exposures to bring it out, but if you go out to a good dark sky, give yourself some time. Give yourself 10 minutes, 15 minutes, 20 minutes. These chemicals build up in the back of your eye, so the longer you stay out, the more you will see. And you will see this smoothly glowing braid that fills the sky. And when Galileo pointed his first telescope up at that, he discovered not milk, but stars. So many stars, so many stars, so many stars that they all just blend together in this smoothly glowing braid. Look at that. That's the wonders of our Milky Way galaxy. And it's covered with these blotchy sorts of things. There are dark clouds of cool gas and dust, hot clouds of glowing, beautiful, amazing color. Space is not empty. Space is full. Space is alive. There's gas and there's dust out there. Not as much gas as in this room, but you add it up over the immensity and you see amazing things. Our galaxy is a wonder. There are several hundred billion other suns, other stars in our Milky Way galaxy. Several hundred billion stars in our Milky Way galaxy. There's 6 billion people on the earth? There's 50 stars for every man, woman, and child on the face of the earth in our galaxy. Our galaxy is huge. It is immense. We see this complex mottled structure because it is filled with hot gas and dust and material. And this is where new stars are born. Here's another wonderful, amazing picture from the mighty Hubble Space Telescope, where you can see this hot gas, and up at these tips is where young stars are being born. Sometimes called the pillars of creation in the Eagle Nebula. This material is all lighting up and glowing because there are young stars pouring their energy out. You can see these dark fingers of cool gas and dust here. And it's complex, and it's dynamic, and it's changing. This is in the Sword of Orion. If you take any pair of binoculars, you point it up at the heavens, point it down in the Sword of Orion just below his belt, and you will see this. This is real. These are actual pictures. This isn't Hollywood. This is as it really is. This is the beauty of our universe, the immensity of it. Those pillars of creation are right here, a smaller piece in this immense archipelago of hot gas and dust, new things appearing. Different colors indicate different chemicals and different temperatures. It is beautiful. This is the Pleiades, the seven sisters. Point binoculars at those. They're beautiful. You'll see so many more stars than anything you could see. Look at this complex structure. There's gas streaming away from things. It is turbulent. It is dynamic. It is changing. It is 1 minute to the next. This is a dying star. This is a star that's in the process of giving up its outer layers. In the center, its outer layers are being pushed out through a wind out into space to be recycled into the next generation of stars. In the center, there will be a leftover object about the size of the Earth, the leftover core of the star that we call a white dwarf. And we can see lots of these. There's a life cycle to stars, where stars shine and then spread their material back out into the universe, creating these amazing objects. We call these planetary nebulae because when the first astronomers looked at them, they were round like planets. But they're giant clouds of hot gas pouring off of dying stars as this material will then cool and get cold again, and then gravity can work its magic and pull it together into the next generation of stars. There's another white dwarf forming in there. These are amazing, amazing, beautiful, beautiful images, and they're real. Now, this is a star that died in a different way. This star died about 1,000 years ago. We have records from the Chinese 1,000 years ago that this star flared up, and you suddenly saw this new star where it didn't exist before. And it was shined so brightly it was visible during the clear blue sky in the middle of daytime for a week, and then it faded back. It was a supernova, a giant star that exploded. And then when we point telescopes at it, we see this. This is the debris of the explosion still spreading out into space 1,000 years later, still spreading out. This material is still very hot, but it will cool. It will be part of the next generation of stars. We can see this going on. Here is a supernova that exploded in 1987. And you can just barely see the shock waves of this hot gas still coming out of there. Amazing things. And the stars, there's so many of them. We do not have numbers for all of them. We don't have labels except for the most interesting ones. The colors tell us their temperatures. The hottest stars are blue. The coolest stars are red and orange. And different masses of stars have different temperatures and different structures. And they're wonders. And they're all suns. Every single one of them probably has their own solar system of planets, their own Jupiters, their own Earths. Look at this. This is what we call a globular cluster. Millions and millions of stars packed so tightly together. If our sun was one of those stars in a globular cluster, the nighttime sky would be almost as bright as the daytime sky because it would be crammed with so many stars, so bright and so nearby. Here's a double cluster of young stars that just formed in our own galaxy. The blue stars are hot. The orange stars are cool. They're arranged. Look at that. Look at that. Every single one of those is a star. Every single one is a sun, each with its own solar system. And they're forming, and they're living, and they're dying, and it's constantly changing and constantly dynamic. And then we see this. 100 years ago, this was called the Andromeda Nebula. Most astronomers thought it was a small cloud of gas and dust nearby in our own Milky Way galaxy, our own great spiral disk of several hundred billion stars, and that was it. They called it our island universe. They thought the Milky Way galaxy was just this one spiral in the midst of an immense empty void, and that was it. And they were wrong, because the American astronomer Ed Hubble studied this very carefully and discovered that this is not a small cloud of gas and dust. That is a whole nother galaxy. Right there in the palm of your hand is another spiral disk of several hundred billion stars, just like our Milky Way. And we start looking around, and there's lots of them. And they're beautiful, and they're amazing, and they're constantly changing. And they're filled with mysteries. We study the orbital speeds. These stars are all orbiting around there. And yet their orbital speeds are fast, amazingly fast. Even in our own galaxy, everything orbits so fast. And if you add up the mass of all the stars and gas and dust and everything we see, the gravity isn't strong enough to hold it in place. These stars are orbiting so fast, they should just be able to escape from the gravity if all that is there is stars and gas and dust. So we think there must be, therefore, a whole lot more stuff there. There must be 10 times more stuff there than just the stars and gas and dust that we see. And we don't know what it is. We call it dark matter. Dark because we don't see it, and matter because it has gravity. But we don't know. Maybe we just don't understand gravity right. Dark matter. What is it? What's out there? Somehow, if we're understanding this right, these galaxies are just the tip of icebergs in this, and the rest of the iceberg is this immense cloud of dark material, maybe some weird kind of particle nobody's ever discovered. I don't know. And we look at these galaxies and we see that they're all moving away from us. Our universe is expanding. Space is expanding and stretching out between the galaxies. And for a long time we thought, well, the only force that could ever affect the expansion of the universe, the stretching out of these galaxies, would be the force of gravity. There's two galaxies colliding together. This giant collision with their stars being stretched out and stirred up as they join together, merging into a new galaxy. Beautiful, beautiful whirlpool galaxy here, another companion right next to it. And the galaxies are moving away from us, and space is stretching out between the galaxies, and we thought the only force which could ever change that, ever affect that, was gravity, which would slow it down. When 12 years ago we discovered the expansion of the universe is speeding up. These galaxies are moving away from us faster now than they ever have been before in the past. We don't know why. There must be some sort of energy pushing galaxies away from each other, and we don't see it, so we call it dark energy. If we understand this right, dark energy, there must be twice as much dark energy as dark matter in the universe. Look at these cool clouds of dust, these dark dust lanes in here where young stars are forming, and that's a supernova. That's a giant star that exploded and is now shining almost as brightly as this whole giant galaxy of several hundred billion stars all put together. It's amazing. It's amazing. Our universe is so filled with wonders, and we are just barely beginning to grasp a tiny little part of it. For everything we know, there are 1,000 questions. 1,000 questions. And every galaxy is different. Every galaxy is, and we look at it with different forms of light. So here's infrared light, there's visible light, there's X-ray light, and we can then begin to peel back the layers to that galaxy and understand what it is and how it works and why it formed the way it did and what makes it similar and different from other galaxies. And many galaxies are in clusters. Here are several thousand galaxies, each galaxy containing several hundred stars, and they're all bound together by this wonderful, amazing force of gravity, and they're all orbiting around each other, dynamic, in motion, changing, constantly different. You can see these galaxy clusters. This is X-ray light from hot gas filling in the space between these giant clusters. Look at every little smudge there. Every smudge there is a galaxy. Here's what we call a central dominant galaxy. This galaxy is way 10 times bigger than our Milky Way galaxy, containing trillions of stars. Its gravity is so strong that it warps the light from other galaxies around it and behind it. So we see these weird distorted arcs. It's called a gravitational lens. Its gravity is so strong that it bends light itself. Amazing things. Here's more of these distorted galaxies from these gravitational lenses. And so we ask, how much is out there? This is my favorite picture from the Hubble Space Telescope. Most amazing one. Because we ask, how much is out there? How big is this universe? How many galaxies? So what they did was they pointed the Hubble Space Telescope at the most boring patch of sky they could find. They looked for a patch of sky where basically there was nothing in it. A little patch of sky up by the Big Dipper. And they did a 10-day long exposure. They just opened the shutter on the Hubble and they just let it gather light. And it gathered light. And it gathered light for 10 days. And they closed the shutter and downloaded the picture and they saw this. This patch of sky is crammed with galaxies. Every little smudge in this thing, other than what? There's like one star in our galaxy here, another star in our galaxy here. The rest, every other smudge in there is a galaxy. Another spiral disk of hundreds of billions of stars. There's about 3,000 galaxies in this picture there. And that's a tiny, tiny, tiny piece of the sky. People could hardly believe it. So many galaxies so far away that ordinary telescopes can't pick them up. So we did the Hubble Ultra Deep Field. That's a couple week-long exposure. And again, we see the same thing. So many galaxies filled with so many stars. You take that tiny little patch of sky and you multiply that over 360 degrees all around us. And what do we got? We've got several hundred billion galaxies visible. Each one containing several hundred billion stars. Each star a sun with its own solar system of planets. Several hundred billion stars per galaxy times several hundred billion galaxies visible in the universe. You multiply that out and you get a number that is bigger than the number of grains of sand on every beach on the face of the earth. Our universe is immense. It is fantastic. It is enormous. It is so filled with wonders and possibilities. And this is what we can see today. Give us 20 years. We will have better telescopes. We will see more. There's so much out there. What we see and what we know is this big. It's tiny compared to what's out there. We are so blessed. We are so lucky to live in a day where we've got these tools, where we can begin to get a little tiny bit of a sense of what is out there, of what really is really and truly out there, of what has been laid out in front of us. We're so lucky that we can see, that we are privileged to live at this point where we can actually know a little bit of what's out there. Thank you for your attention.
When I look at your heavens, the work of your fingers, the moon and the star that you have established, I ask myself, what are human beings that you're mindful of them, mortals that you care for them? You've made them a little lower than God. You've crowned them with glory and honor. You've given them dominion over the works of your hands, and you've put all things under their feet. All sheep and oxen, and also the beasts of the field, and the birds of the air, and the fish of the sea, whatever passes along the paths of the seas. O Lord, our sovereign, how majestic is your name in all the earth. God, we use this phrase and we use it often, and I think perhaps flippantly we say, you're big. We say, God is big. And Lord, we're confronted by the simplicity of that statement. God, that you are not a God who calls us to solve you, to explain every aspect of you, but you are a God, particularly through your Son, Jesus, but through the full narrative of Scripture, God, who has made yourself known, who allows us to know enough about you to have personal, intimate relationship with you. And God, we're dumbfounded by the fact that in light of how massive creation is, that you care for us. That despite all that you've got going on, you're worried about acceptance letters to colleges. You're worried about hangnails and junior high relationships and jobs and budget shortfalls, cancer, aging parents. God, it defies logic that in light of how massive creation is, you would be as personal and intimate as you are. And yet we claim that is true, God. God, we want to walk with you in a way that hallows your name, in a way that glorifies you. Thanks, Jesus, for your Son. Amen.